Alright, so today we need to learn about Dalton's law of partial pressures. And if you look in your homework notebook, that thing, it's on page 4, are all the formulas for the gas laws. So that's where to look. Alright, anyway, Dalton's law of partial pressures says that the pressure total equals the pressure of gas number 1. That's what that little 1 stands for. Plus the pressure of gas number 2 plus the pressure of gas number 3, dot, 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 because this could go to infinity, I guess, if you had more gases, but normally it's only a couple. So basically it says, what is the total pressure when 3 atmospheres of oxygen gas is combined with 4 atmospheres of chlorine gas? Well, to do Dalton's law of partial pressures, it's just PT, I abbreviate total with T, is going to equal the pressure of gas 1, which is oxygen, so you just go 3 atmospheres plus the second gas is chlorine gas plus 4 atmospheres, and so 3 plus 4 equals 7 atmospheres. Okay, does that make sense? It's kind of like if you're putting air in a tire. If you put some air in, and then like if you add 3 atmospheres of pressure, then you add 4 more atmospheres, you're going to get more pressure. Now, you need to, I hope you did the simulator, because what's going to happen, if you have 3 atmospheres, here's your container, and let's say there's 3 atmospheres of gas in there. Why do gases exert pressure? Well, they move, and when they hit the side of the container, they exert a force which causes a pressure. So when they're striking the sides of the container, they cause a pressure. Well, if you have 3 atmospheres, that's 3 atmospheres of however many particles. Okay, but if you add 4 atmospheres more of a different gas, what you would be doing is you would just be adding a different gas, and that's going to, I wanted to make that a different color, but whatever. Okay, you'd be adding a different gas, and so you're going to have more particles hitting the sides of the container to cause more pressure, okay? But what you basically need to know is that the total pressure is the pressure of all the individual gases added together, okay? Yeah. Right, you couldn't add together an atmosphere and a millimeter of mercury, correct? You want to add together the same, make sure they're in the same unit, okay? All right, now here's one kind of going a little bit backwards, but a mixture of gases inside a container has a pressure of 8 atmospheres. So we know that the total pressure equals 8 atmospheres. Okay, if one of the gases is chlorine and it has a pressure, so we know that chlorine is equal to 3 atmospheres. Well, what must be the unknown gas? What's the pressure of the other gas? We don't know what the gas is, but we don't know its pressure. So basically, you would just go the pressure total, oops, let me just go, is 8. So 8 atmospheres, the total pressure is equal to the pressure of the chlorine, which is 3 atmospheres, plus the pressure of the unknown, which is, we'll just say X atmospheres. So basically, what number plus 3 equals 8? 5 atmospheres, okay? You'll see when we do a lab tomorrow, we're going to do a lab, you'll see how you use this thing, okay? You actually use this. It seems like a pretty simple thing, but you'll see how it works. Basically, what we're going to do tomorrow, here I'll show you how we're going to use this. Tomorrow, we're going to have these long tubes, and I'm drawing horrible, and they're going to be underwater because we're going to collect the gas underwater. And so we're going to collect this gas in this tube. It's going to displace water, you'll see. But the problem is water vapor is going to get inside this tube. And so that's water vapor means water that's a gas. It kind of contaminates it. Does that make sense? So we got to subtract how much contamination we have to figure out the pressure of the gas that we collect. And so we're going to use Dalton's law of partial pressure because we'll know the total pressure. We'll know the pressure of the water that contaminated it. There's a way to figure that out. It's just a chart. You look it up. And then because we want to get the pressure of the gas that we collect. You'll see. I'll show you tomorrow. All right. I know that doesn't make sense to you, but you'll get it once we do it tomorrow. All right, that's Dalton's law of partial pressures. Now, we're going to be doing this combined gas law problems, which it basically puts Boyle's, Charles, and Gay-Lussac's law all into one big problem, which says pressure 1, volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. So you should write that down or know just where to find it on your formula sheet. Okay? Because you're going to see, I'll write it down when I do the problem over here, but you're going to see how you use that. Okay. So here's how it goes. You're going to be given these big, long word problems, okay, that look like this. Now, I'm going to show you a strategy for doing this to keep things straight because people get mixed up on these, especially like if you have trouble reading sometimes and figuring out what's what. Here's what you need to do. You need to make a list of the givens. So on any gas problem, you can make a list. And the list is always P1, P2, V1, V2, T1. Oops, I didn't want to do that. Back to my pen. I don't know how that did that. T1, T2. Oops, that's supposed to be T2. And then what you do is you read the problem. 7.9 liters. Would liters be a pressure unit, volume unit, or a temperature unit? Volume, okay, so that's going to be 7.9 liters. It's important to write the units down. With a pressure of 1.2 atmospheres, that's going under pressure 1, it's important to write the units. And a temperature of 18 degrees Celsius, so 18 degrees Celsius, okay, is heated until the volume is 8.4 liters, so the volume is going up. It's going up to 8.4 liters. And the pressure is 1.9 atmospheres. 1.9 atmospheres. And it says, what is the new temperature in degrees Celsius? So it wants the new temperature. Okay, so the first step when doing these problems is to make sure that you have your temperatures in which unit do the temperatures have to be in? Who could tell me that? All gas law problems, the temperature always has to be in a certain unit. Kelvins. How do you get to kelvins? You do what? Right, add 273. So take that 18 and change it to kelvins. You have to work in kelvins with gas laws. So always do that. So take this 18 and add 273 to that because you always want to work in Kelvin. So I get 291 kelvins, okay? So you're going to want to write that down. Always work in kelvins, 291 kelvins. Okay, now watch what I'm going to do here. After you list the givens, I find it helpful to write the equation because some people mix up where things go. They don't put them in the right spot. So you go P1 V1 over T1, not T2, I don't know why I wrote that, over T1 equals P2 V2 over T2. So write the equation. Next, plug in the numbers. So I'm going to plug in P1, which is 1.2 atmospheres, times V1, 7.9 liters, divided by T1, which is 291 kelvins. That's going to be equal to P2, which is 1.9 atmospheres. Now, here's the thing. I think somebody asked this question earlier. Guess what? Your pressure units have to be in the same unit. Do you get that? They have to both match. It doesn't matter as long as they both match. Okay, they could be in millimeters mercury as long as they're both in millimeters mercury. But make sure that they match. Same with your volume units. They have to match. You can't have one be like milliliters and 1 liter. Okay? Liters. Okay? Now, here's what we're looking for. We're looking for T2. Okay? Now, I'm going to show you a math strategy. one thing about math is you have to get things out of the bottom. Okay, that's called the denominator, right? If I got my math terminology correct. So you have to get it out of there. So how I like to say to do it is you cross multiply. Have you heard of that before? So I'm going to cross multiply to get everything on the top. So I'm going to take T2 and cross it over here. And I'm going to take this one and cross it over there. So I'm going to basically get T2 times 1.2 times 7.9. Now that I know all the units are okay, I'm just going to leave them off, equals 1.9 times 8.4 times 291. So I'm going to do all that math. Okay, so why don't you go ahead and push the buttons in case I make a mistake. You can tell me if I make a mistake. Oops, that should be 0.3. I made a mistake there. All right, so I get T2 times 9.48 when I multiply those two together equals 4644.36. So did people get that? So now I'm going to divide both sides by 9.48. So I'm going to divide to isolate T2. So I'm basically going to take what I got on my calculator and go divide by 9.48. Now I get that T2 equals, I got 489.9. I'm just going to round it to 490. Is that okay? So I round that to 490. But now what units am I in when I get that temperature? We're in kelvins, okay? But it wants you to be in Celsius. So how do we change kelvins to Celsius? Minus 273. So take your number and subtract 273, and I get 217. All right? So that ends up being 217 degrees Celsius. Okay? You see how a problem like that works? You list the givens and then put them in. All right. Let's try a different one here. I'll let you just try this. I'm going to stop this recorder thing. It's too long.